Hello and welcome to all in this video lectures series on C programming. In today's video session, we are going to talk about one of the most important concepts that exists in C programming language, which is known as pointer. So, before going to see the exact meaning of pointer and its application in C programming language, let us have some quick discussion about a variable declaration, right? So when we talk about this concept, that is what simple a variable, we know that as per the theoretical concept, the variable is basically an entity whose value is going to change during the program. Okay, so simple, when we talk about the variable declaration, so the variable is generally declared in this way: the first data type and then name of variable, right? So this is a generalized syntax about this variable. So when I'm going to talk about it, basically the data type defined, mainly it is used for two basic purpose. The first, it define what kind of data or which kind of data that hold by this variable, right? And the second one is what, the most important, it is going to declare about a reservation of memory. So for example, suppose we are there or in our program we want to handle a simple, say the integer value, then we are going to declare in this way, say integer x. If we are interested to hold the floating point value, we are going to declare, say, float y. And for simple single character, I will say this character z. So when I am going to talk about this entire declaration, so first this define the data type, right? So what it is going to indicate, the x is a variable, right, which is going to hold what, the integer value. This define y is again a variable which is capable to hold the floating point value, whereas z is again variable which holds the character value symbol, right? So now as we know that the first objective is fulfilled by this variable declaration. What the data type define? Data type mainly defines which kind of data that hold by this variable. Now the most important one, what is that? Say simple, the reservation of memory, right? So when simple, I am going to say, I am going to declare this integer x, and suppose I am going to assign some value, say static, say it's a 5, then what will happen? Simple, whatever the memory is there, right, which is there that we are going to use during the program execution, right? So no doubt each of this memory is consists of a different slot. Say I will say this is my slot number 1, slot number 2, slot number 3, up to say slot number n. So it is totally depends on a memory capacity. So simple, suppose I am there with this 64 KB by 8. What it indicate? It represent the size of this one single, what we call the slot here. Okay, means at one specific location 8 bits can be easily stored, and 64 bit means what? It's a total capacity. So corresponding to this 64 KB, what will happen? Right, so my initial value is 0000 and the final value is what? It's a FFFF in hex value, right? Or the initial value is 0000 and the final value in decimal is what? 65531, right? So what is this? This initial value, final value means what? It is the address associated with each of the slot. This is what my slot number 0, this is slot number 1, this is slot number 2. In this way the last slot address will be what? 65535, right? So the moment at which I am going to declare this integer x is equal to 5, in short, again what will happen? Whatever the available memory is there with me, right, out of that memory, say when I am going to consider a machine the system with more than what we call that 32 bit, right? So suppose initial my address is 1000, right? Then the next address 1001, 1002 and 1003. These are the various slots which are present here, right? Above this some memory slots are there, and below this again some memory slots are there. Out of that, the moment at which I am going to declare integer x is equal to 5, what will happen? Simple, these 4 bytes are reserved with a name as x. Just try to get this. We had already discussed this in some initial video sessions, what exact thing is happening when I am going to declare a variable. In short, when we are going to declare a variable, depending upon its data type, that many number of bytes of the memories are reserved, and now the name given to that memory byte is what? X. And here simple, right? In short, the value 0, 5 is get stored. No doubt it's there into binary format, again converted into ASCII, hex, and finally the binary means 1000 up to 1003. Within this entire location, this value 05 is stored here, right? And now I'm going to say that the first memory location address is nothing but what? This is a address of variable x. So these are the things that are happening when I'm going to declare one simple variable over here. Even though if I'm going to suppose declare float y, what will happen? As the float 4 bytes are required, then whatever available memory is there, out of that the 4 bytes are reserved here, and whatever the first location is there, the first location's address is treated as a address of this variable. Now, so when I'm going to talk about the address of variable, then this AND sign is mainly used in order to return the address of variable. So what it does, simple, it returns the address of variable. So whenever this operator is read as the address of operator, right? So no doubt, as per our digital electronics, we say that this is the AND sign, but here what we are going to say, this is what simple, the address of variable. Okay, so in short, what happens, simple, the moment at which we write ampersand x, what will happen? It returns the address of variable x, the x variable, right? The moment at which I am going to define ampersand x, right, it is going to ampersand in the sense the address of variable, address of variable operator, which is also pronounced as ampersand, and it is read as what? The address of. So address of x here, right? So as per the previous discussion, the first memory location 1000, 1001, 1002 and 1003, right? As per the what we call the previous discussion, these are the 4 memory bytes are there which are get reserved here, right? And the name given to it is what? X, right? So the address, if I am going to write here in this way, ampersand x and simple suppose x, so what will happen? The moment at which I am going to declare integer x is equal to 5, what will happen? If I am going to print simple the value of variable x, my output is, right, I repeat, when I am going to declare the printf %dx, what will happen? Here the value of x is written, that is what? 05. However, if I am going to use this ampersand, which is read as what? The address of x, here I am going to get the value as what? 1000, right? So in short, this AND sign, which is pronounced as ampersand and read as what? Simple, the address of, right? So the address of variable, right? Okay, so what will happen? The moment at which I am going to deal with it, whatever the available memory bytes are there, the first memory location is considered, or the first memory location's address is considered as what? The address of the variable. Okay, so let us cross check this with one simple example. Okay, so now I'm going to let me save this. So now I'm going to start the programming. Here hash include stdio.h, then hash include stdlib.h, then void main, and here I am going to declare this, say integer x is equal to say 5, right? Now what we did, simple, I am going to make use of one simple variable x, and to that variable x I am assigning a value 5 here, right? Now say printf %d comma x. So what will happen? At this, I'm going to get the address, sorry, the value assigned to the variable x here. And now I'm writing here printf, see, %d, comma ampersand x. Okay, so just check out here /n. Okay, so let us find out what will happen. Here I am going to defining first. I am interested to print here simple the value of x, and here ampersand x, that is address of variable x. So let us go with, say, stepwise execution. Let me remove the earlier file. Okay, just build it out. Okay, or okay, to understand it, fine. Okay, let me declare one more variable, say y, and now I'm going to define to understand it. Say y is equal to ampersand x. Okay, and here, say, I'm going to define here the y symbol. Right. So what will happen here? The x is there with me. Okay, and now y is equal to this ampersand x, that is address of variable x. So what will happen here? Whatever the memory location is there where the name x is assigned, that memory location address is returned and it is given to the variable y here. Okay, so let us go with the stepwise execution. Okay, so let me enable the code window. Okay, right, we are there with this. Right, so the first x is equal to 5, the value 5 is get assigned to variable x, and now y is equal to ampersand x. Check out it. So 62642240, this is the memory location address where the value 5 has been stored here. Okay, so, and when I'm going to execute it, at last I'm going to get the output like this. Okay, so we are here with this. So the 5, that is a value assigned to the variable, and this is the address of variable that is written here. So now why it is happening? Because we are using this ampersand operator, which is nothing but what? The address of variable x. So at this step we are going to make use of, or we are going to return, or we are going to store the address of variable x into y. In short, at memory location here as indicated, which is that 642240. So at memory location 642240, the value 05 has been stored. Means the 4 consecutive, that is 40, 41, 42 and 43. At these 4 different memory location, this value has been stored here. So in this way, this ampersand, that is address of what you call the operator, generally works. Now the most important one, what is that? Pointer. So what is pointer? The pointer is a variable that store the memory address. In short, it is used to point out the data present as the specific, or at the, okay, this should be at the specific memory location whose address is mentioned. And its syntax is what? The data type, this asterisk mark, and the name of the pointer. Right, so simple. The p name defines the name of pointer variable, and ampersand defines, okay, what is that? This p name is nothing but what? It is a variable which is going to use or going to work as what? Simple pointer here. Okay, so to better understand this, let us consider again the same declaration. I will rewrite the things here. Say I am going to declare again integer x is equal to 5. So what will happen? I will treat the first memory location, say 1000, right? Second 1001, 1002 and 1003. So these are the 4 consecutive memory locations, and collectively at these memory locations, what will happen? Or to these memory location, the value or the name x is assigned here. Okay, so the name x is assigned, and here the value 05 is stored. Right, so here the value 05 is stored. So when I'm going to talk about it, right, so if I'm going to print simple, say print f %d x, what will happen? the value of variable x. What is the value of variable x? In our case, the value of variable x is what? 5. So the value 5 is returned here. I'm going to get the output as 5, and then I'm going to write simple printf as just we have seen %d ampersand x. What will happen here? The address of variable x is written, and what is that address? It is going to start from 1000. So now 1000. So this is a memory location which is the first one for variable x that is given at the output side. Okay, so these two are here, right? And now the most important one, say the next step that I am going to declare is what? Simple, the pointer. So integer pointer y. So what it defined, the first of all I am going to make use of this asterisk mark. So that's why the y is nothing but a variable which is going to work as a pointer. It is going to point out some memory location. Okay, the data present at the memory location, and as it is going to point out the integer value, we are going to declare its data type as a integer. So now I'm going to write, say y is equal to ampersand x. So what will happen? The value of variable y is now 1000, and here I am going to print simple printf %d simple y. So what will happen? The y is going to return. Just try to get this asterisk mark, that is pointer y, is little bit different and simple y is different. Right now what we are doing, we are dealing with only this simple y, and what is the value that present in y? It's a 1000. It is nothing but what? This entire declaration return the value which is this 1000, that is 1000. This value is given by this entire expression, and now this value is get assigned to variable y, right? So now %dy, what will happen? The output that I am going to get is what? 1000. And now the next, okay, when I am going to write the most important one, printf %d comma this asterisk, that is pointer y. Now these two declarations are totally different. Here I am using this pointer operator, and because of that, what it does? Simple, this pointer operator defines, okay, the value present at address. Which is that address? The address is nothing but what? Hold by the variable. Okay, address hold by variable. In short, when I'm going to write here the y, right? So here whatever the value of y is there, this value of y is treated as simple memory location address. Memory location address. So what will happen when I'm going to write here this pointer y? The content of y are now treated as a memory location address, and what is that? This. Okay. So now in short, what will happen? This is nothing but what? Asterisk, that is pointer 1000. So in short, this entire declaration point the value present at location 1000, and what is that value? 05. So at the output side I am going to get the result as what? 05. So in this way, simple, the pointer is used to point out the value present at address, right? So the two most important concepts that we had just now discussed, what is that? First, this ampersand. Okay, what this ampersand does? Simple, it is going to return, or it is used instead of making or using the word as return. Let us consider what it does. Simple, ampersand means what? It gives address of variable, right? If I am writing ampersand x, then it is going to give the address of variable x. If I am writing say ampersand etc, the etc is treated as a variable and its address it is going to return. And now suppose I am writing this, that is what? This sign, that is asterisk mark, which is nothing but a pointer. So what this does? Simple, it is going to return value at address. Just try to get this. It returns the value at address. In this sense, if I am writing say asterisk dkte, what will happen? the dkt is first treated as variable, and the content present in this variable, means the value held by the variable, is treated as address, and the content which are present at this address are reflected at the output side. Okay, so again let us see the same with the help of demonstration. So I'm going to consider this. So now I will declare this y as say simple my pointer. Okay, so y I am going to declare as a pointer. Okay, so simple. So one by one I'm going to declare it. So here simple, suppose first I'm going to declare the address of x as it is, right? Then now here I'm going to execute what, simple this y, and after that this pointer y. So just try to get this. Here I am going to get simple the value of x. What is that value of x? It's a 5. Then ampersand x, what it does, simple, it is going to return the value present at, or the value held by the, or the sorry, the address of variable x, the memory location where the value label x has been assigned. And now y means what? Simple, here the address of variable x is assigned to y, and the moment at which I am going to execute this, what is that, say pointer y, what it does, simple, the location, right, whose address is there in y is displayed on the output screen. So step by step we will go with it. Okay, so first let me build it. So let me build it first. So here, right, so first the value of x is 5, and when I am going to assign it, what will happen, now the address is changed, so dynamically the new address has been assigned. What is that? It's a 61FE14, somewhat like this, right? So let us check out what will be my first outputs. Here I have displayed the value of variable x, so variable x value is 5, that I am going to get on the output screen. The next one, it's address, so whatever this address is there, what is my address now? It's a 6422036, right? So it is nothing but what, the memory location 6422036, 3738 and 39, these 4 memory locations are termed with the name as a x, right? Now let us find out the value of y. So what is the value of y? The value of y is again same. Why it is same? Because the same address we are assigning to variable y. And now when I am going to execute the last statement, what output I am getting? I am getting the value as a 5. So what happened in short? Here, due to use of this pointer variable, the 642230 is treated as a memory location address, and at this memory location address, what is there? The value 05 is present, and that's why that value is displayed on the output screen. So in this way, we can use the pointer to point out the value that present at specific memory location.